All right, in this video, I'm going to explain the sieve analysis test and talk about the report that you're going to create. And I'm looking at Polylearn under the sieve analysis section, and there's a few videos I've created that show the process of sieving, and it's explained in the videos. So you're going to watch those videos, and while you're watching the videos, you're going to want to have the data sheet available so you can record the data that you'll need to create the sieve analysis. Grain size distribution is what it's called. So to make the grain size distribution, you have to collect the data. The data is provided in the video, so you want to have the data sheet. Now the data sheet is here under the experiment summary. So the experiment, if you click on that, it looks like this. This is your first report is going to be due next week, and it's a letter type of report, which means it's essentially a letter that provides the results. And it's going to follow this type of format because this is the letter type of format. So I'm giving you the assignment in the same style or the same format that you're gonna use to create your letter report. All right, so let's see. This first paragraph, let's see, I'll just read this. The letter report uses a business letter format that transitions directly into reporting. Remember to use active voice, use meaningful verbs, avoid wordiness. Provide a brief introductory paragraph indicating the test you performed and your visual classification of the soil. So this soil that we're using is sample 1 from the visual manual classification. So sample 1 is the one that we're doing the sieve analysis on. All right. So there's not going to be a whole lot to this report. We're going to make a table and a grain size distribution figure. And then we have a little application where we're going to use a really simplified approach to evaluate bearing capacity. And I'm going to talk that through in a moment here. But before that, I want to just skip down to, let's see, you have to include these things. You're going to list your attachments. You'll have your handwritten data sheet and just one set of sample calculations. It's pretty straightforward for this one. You're going to have sample calculations for this bearing capacity activity too, which I'll describe in a moment. But I'm going to I'm going to skip the bearing capacity part for a moment. I want to get down to the data sheet. So here's the data sheet. You can be the tester, and we can use the date of the lab as the date. This data you're going to be recording you're going to record this from the video. So dry mass of original specimen, that's the most important that's the basis to calculate the percentages retained or passing each of the sieves. So this is the most important number to record, and that's from the video. So make sure you get that. Dry mass of specimen after wash. So since soil has silt and clay in it, and those particles are so fine, they clump together, they don't tend to, those clumps won't separate during the agitation. If you have a stack of sieves and you agitate it, they're not going to separate. So for that reason, we have to wash that material out, and then everything that's retained on the number 200 sieve, which is the one that indicates the difference between sand and gravel and fine grain silt and clay, we have to separate all the fines and then take the sand and the gravel and then perform the mechanical sieve analysis on that material. And when I say mechanical sieve analysis, what I'm talking about is you have a stack of sieves, with the larger sieves on top, progressing down to smaller sieves, and then there's a pan on the bottom, and you put the material into that stack of sieves, and you take it to the sieve shaker and you agitate it, and the particles fall down on the sieves that they want to rest on, and then you weigh the mass retained on each of the sieves, and you calculate the percent retained, and then you calculate the percent passing, and then we can create the grain size distribution. Okay, so you're going to fill out this data sheet by watching the video. You'll have the original mass of the specimen from the video. Okay, that's going to have the fines and the sand, everything. Then we're going to wash out all the fines, and we're going to take everything that's retained on the 200 and put it back in the oven and dry it, and then We're going to weigh it when it's oven dried, and that's going to be the dry mass after the wash. And then finally, if you take the difference between the two of those, those would be the fines that were removed from the wash. Okay, this is the data to record the mechanical sieve analysis. So you'll record the sieve number, the opening, and then the cumulative mass retained. So let's just say, for example, I'm going to go here. Let's just say, for example, our first sieve was like the sieve number was the 4, and the size of that is in millimeters is 4.75, and then its cumulative mass retained let's just say it was 10 grams, and then it's percent retained and percent passing. And let's just say, for just easy calculations, let's say the original dry mass of the sample, so this is with all the fines, everything, and this is the basis for all the calculations. Original dry mass of sample let's say that was equal to 100 grams. Okay, so for the percent retained, if we had 10 grams, 10 out of 100, that's 10%. And 100 minus 10%, that means 90% of it was passing. And then we just kind of work our way down. The next sieve, I don't know what we have on the stack. Number 8 sometimes a lot of times is the next one. I think that's 2.36 millimeters. Let's say we had 20 grams. So it would have 20 out of 100, 20% retained, and 80% passing. And you just work your way down all the way till you get to the pan. And in the pan, so we'll probably have some fines in the pan as well. So let's just hope that after we've kind of finished this all up, I don't know, whatever we have left in the pan. Let's say, before we talk about the pan, let's say that our dry mass after the wash let's just say that equals 80 grams. Okay, so we washed out 20 grams of fines. Okay, so let's say the only reason we measure the dry mass after the wash is so we can compare continuity. And I talk about this in the videos too. I'm just kind of explaining it twice. So let's say we get all the way to the pan, and we just want to check that we have about 80 grams. So maybe we have 79.9 grams in the pan. Okay, that's pretty close to the 80 grams. Okay, great, check. We didn't make some big mistake. And of course, you don't need to kind of fill out any percent retained or percent passing for the pan. It doesn't make sense. Okay, so that's just kind of a quick review of calculating the percent passing. And with this data, we're going to create the grain size distribution. So grain size distribution curve, that one. Typical format for geotech is we have percent passing, and so this is percent passing, and this is the grain size. In millimeters or whatever. And this one is on an inverse log scale. So just format this axis so the numbers are bigger here and they get smaller as you go this way, and it's also on a log scale. So I'm just going to write And don't write inverse log scale when you make your graph, but I'm just going to write inverse log scale so you know, and that's a standard kind of format. So inverse log scale. So let's say for us, usually you want to have a point up here for 100% passing, and then we have our next one. Let's just say this is the number 4. So this was 4.75, and we had, that was 90% passing. So you're just going to plot out all your points and then connect those with probably just straight line. You don't want some kind of funky curve that has like points of inflection. Just do a straight line in between the points. And it'll come down here. And our last data point at this point right now is right here, and this is the number 200 sieve, because that's the material that we're sieving. So this is 0.075 millimeters. So that corresponds to the number 200 sieve. So later we're going to extend the curve. Next week we're going to do what's called the hydrometer analysis, and we're going to extend the curve beyond the number 200, and we'll get some additional data points, and we'll get the grain size distribution of the fines, and we'll go ahead and extend our grain size curve. But all these data right here are going to be coming in the future from the hydrometer test. And all this is from the mechanical analysis. That just means we shake it in the sieve shaker. Oops. Mechanical. Okay, so when you make this plot, it's percent passing and grain size. So in your data sheet, it's the size and then percent passing to make that. Let's go back and look at the other report requirements here. I'm going to make another part to this video to talk about the bearing capacity part of this write-up. So right now we're just going to talk about just the graph we're going to make. Okay, so back to the instructions. You have an introductory paragraph, then you have your summary of findings. If you have tables and figures, always have a sentence that introduces the table or figure before you just present it. And every table and figure needs to have a table number or a figure number and a title. And for tables, that goes above the table, and for figures, that goes below the figure. That's just standard formatting procedure. So here's what you have to have in this section. So you'll tell us about what you're going to include, and then you're going to have it here. Include a properly formatted grain size distribution figure. That's what we just talked about. Provide a table with the percentages of gravel, sand, and fines. Okay, so these are defined by the different sizes that we talked about. And then it says, and then you're also going to have D60, D30, and D10 if possible. And so what that means is, it's best to kind of show this by example. If we wanted to evaluate, let's say D60, so we'd go over here. Let's just say this happened to be, well, whatever, that's fine. Let's just say this happened to be 60% passing. And if we wanted to identify D60, we'd just kind of go straight over here and then straight down. And so that value right there would be whatever D60 is. And this is on the inverse log scale, so when you read these off, make sure you're reading the log scale correctly. So that's D60. If you wanted, D50, you'd just do the same thing, and D30. And it says do D30 and D10. So our last data point right now is at the number 200 sieve, and depending on the fines content, so anything that's finer than the 200 sieve are fines. Okay, so depending on the fines content, I don't know what this value could be, what this value is at, right here at this last data point. But if it's anything greater than 10%, then we aren't going to be able to. Let's just say, for argument's sake, at the moment, let's just say it's like 31%. Let's just say that. That's what this value is right here. So if we wanted D10, we'd have to come down here and come across, but we don't have this defined yet. So we wouldn't be able to report D10 because the grain size curve stops for the moment, for my example, at 31%. And if you're asked to find D30, if it's really close to 30%, as far as if the last point is at 31, then just kind of estimate what it is. But if our last point is at like 40% or something, then just say for D30 that it's not applicable, or make a note that we can't evaluate it right now and we'll have to wait till we have the hydrometer data. Okay, so that's D sub X or D10, D50, D30, whatever. That's something that we use to help classify the soil later when we have these results. Okay, so let me go back to the report requirements. So make the grain size figure, have a table with these things, gravel, sand, fines, include the likely soil classification, that was sample 1. And then you'll have another section on bearing capacity. I'm going to stop this video and just make another part for bearing capacity. Okay. If I can make this stop. Just